Today we're in section 5.1. We're learning about rational numbers today. We should be in our textbook on page 219. There's several examples today, but a lot of the examples relate to each other. Anyway, let's go ahead and get started by talking about rational numbers. What makes a rational number? Well, a rational number is a number that can be written as a quotient of two integers. What does quotient mean?
Divided.
It means division. So I can show that by showing the number as a fraction, a over b. Okay, so the very first section of your homework section tonight, and in our first example, we're writing the integers in a over b form. We're basically just writing them as fractions. So let's do a couple. Let's practice. All right, what if we had, let's say, let me go over here to example 1. What if we had the number 7? The number 7, and it said, show that the number is rational by writing it as a quotient of two integers. The quotient shows division, so how can I write the number 7 as a fraction? 7 over 1.
Oh.
Okay, 7 over 1. How could I write negative 10 as a fraction?
10.
Negative 10 over 1. And make sure that you attach that negative to either the numerator or the denominator, but it must be attached to one of the numbers. If it's floating out front, in front of the fraction, you're going to lose the points for that because the negative has to be attached to one of the numbers. All right, so in the next one, I have a mixed number. Now, anytime I have a mixed number, I need to write it as an improper fraction. If I'm trying to show it as a quotient of two integers, well, if I leave it as a mixed number, that's 3 integers, okay? So I need to change it to an improper fraction. What is 5 3/4 as an improper fraction? It's going to be 23 over 4, okay? And that's going to be my answer. Now, on the next one, it's negative, okay? But I still change it to an improper fraction the same way. What's going to be my improper fraction?
Negative over 2.
Okay, it'll be 7 over 2. So it'll either be negative 7 over 2, or it'll be 7 over negative 2. Again, as long as you attach your negative to either top or bottom, you're good. Okay? And that's how you write numbers as rational by writing them as a quotient of two integers. All right, now in example 2, we are now dealing with terminating and repeating decimals. Well, a terminating decimal, let me just give you 2 examples. Okay, one I have, let's say I have this. And then another, let's say I have this. And another one, let's say I had this. Okay? To tell whether or not a decimal is terminating or repeating is very simple. If the decimal ends, it's a terminating decimal. If it keeps going and shows a pattern, it's repeating, and I show a repeating decimal by using what I call bar notation. Okay, now I understand that last year some of you may have used the ... We're not going to use the ... We're going to use the bar above the number that's repeating. So in the first example, in this first number, only the 4 is repeating, so I only write the 4 one time with the repeating sign above it. In this third one, the 2 and the 4 are repeating, so I have to write both numbers with a bar over it. Okay? You might have some instances where only one of the numbers is repeating. So make sure you only put the bar over the number that's repeating. All right, these are just random examples. All right, so in the next couple of examples, I'm going to go from fractions to decimals and from decimals to fractions. In this first example, I'm writing these fractions as decimals, so I'm going to put it in my calculator. I can either divide 3 divided by 8 and change that to a decimal, or I can use my fraction button on my Casio calculator, 3 over 8, and then change that to a decimal. What would you get for your decimal value? Yeah. What was it? Nope. 0. Nope. 3 divided by 8. 3 divided by 8, guys. What's it going to be? 0.3. Get out your calculators.
Wait, 0 divided by 8?
3 divided by 8. 0.375.
Oh, it's 3.
Okay, guys, we're just changing this fraction to a decimal. I just explained how to do it. We're going to divide top by bottom, or you can put it in your calculator as a fraction and then convert it to a decimal by pressing your S to D button above the delete button. All right, now I want you to change 5/11ths to a decimal. All right, what's it going to be? Just tell me.
0.45 repeating.
Okay, 0.4. Is the 4 and the 5 repeating?
Yes.
Okay, since both numbers are repeating, the bar goes above both numbers. All right, so I'm just changing fraction to a decimal, just using our calculators. All right, now let's skip over now to example 3. Using decimals to compare fractions. Now, this is a practical method of comparison when my denominators, it's not easy to find an LCD, because last chapter we already learned how to compare fractions using an LCD. All right, so let's read this example. It says, of the 50 mammal species found in Canyonlands National Park, 20 species belong to the order Rodentia. Of the 54 mammal species found in Badlands National Park, 24 belong to Rodentia. In which park is the fraction of mammal species belonging to Rodentia greater? Okay, so how could I write this first set of numbers as a fraction? Would it be 20 over 50 or 50 over 20? Okay, well, which one is the total? 50 or 20? 50 is the total, and we know that the total always goes in the denominator. The total always goes in the denominator, so 50 is in our denominator and 20 is in our numerator. What about that second set of numbers? What will it be? Hold on, what's my total? 54. Okay, so 24 over 54. But before, in the last chapter, we would simply find an LCD. But an LCD for 50 and 54, that's going to take a long time. So there's another way that I can compare them that's much easier. I can just change my fraction to a decimal. So let's go ahead and convert 20 over 50 to a decimal and 24 over 54 to a decimal, and then compare their decimal values. All right, so what's 20 over 50 as a decimal? 0.4. What about 24 over 54?
0.4 repeating.
0.4 repeating. So which one is the greater fraction? 0.4 repeating. So there's a couple ways that you can write that. You can say 20 over 50 is less than 24 over 54. You can say 24 over 54 is greater than 20 over 50. Or you could compare their decimal versions. 0.4 is less than 0.4 repeating. Okay, but I want to see that comparison. Don't just say 0.4 repeating. I want to see the comparison. It's less than. I think it just helps us to stay in that pattern of I'm comparing two numbers, so I have two numbers in my answer, and I use an inequality to compare them. All right, so that's it for example 3. Now in example 4, now I'm going the other way. Now I'm going from a decimal to a fraction. The most important part about converting a decimal to a fraction is to look at this last place of your decimal number, okay? The last place value of your decimal, whatever place that last digit is in. Okay, so for the first number, what place is the 7 in? What place is the 7 in on the first number? It's in the 10th place. Okay, so 10 is going to be my denominator, and whatever number is in my decimal, that number is going to be in my numerator. Now, can I reduce that? No, I can't, but I need to always ask myself if I can reduce, because if I can, I need to make sure that I do. All right, now on my next one, okay, would this be just a fraction or would it be a mixed number, and why? It's going to be a mixed number, and why do you think so? Because there's a whole number out here, right? Well, since there's a whole number out there, I know that this is going to be a mixed number. So is it going to be 3 or negative 3? Negative. It's going to be negative 3. And what number goes in my denominator? 100. What number goes in my numerator? Okay, final answer? Why not? Have to reduce. How can I reduce 5 over 100? What does it become?
5 over 1 over
Negative 3 and 1 over 20. All right, you think you can do the next one? Okay, so what goes in my denominator? Yes, it's going to be 1,000. And then what number goes in our numerator? Just a negative 2. Now, let me ask you this. Can the negative be floating out here in front? No, it just needs to be attached to either the top or the bottom. I prefer the top. Okay, but is that it?
No.
Nope. What do I reduce it to?
1 over 500.
Negative 1 over 500. Negative 1 over 500. Okay, now my last one, is this going to be a fraction or a mixed number? Mixed number. 1 and 62 over 100, right? Final answer?
No.
Why not? Have to reduce. Can reduce by 2, 1, and 31 over 50. All right, so one of the most important parts about changing a decimal to a fraction is, 1, that you remember to reduce, and 2, that you just get your denominator right. Whatever that last digit, whatever place that last digit of your decimal's in, that number goes in your denominator. Now, with repeating decimals, guys, there is a pretty complicated way that we can do it. I may choose to revisit this concept later, but for now, I just want to go ahead and write repeating decimals like I would write a terminating decimal. So in example 5, if it gives you 0.93 repeating, I just want you to look at the last digit, basically, of our repeating decimal that's written, and then just write it 93 over 100. I know that this seems pretty simple. Like I said, I might revisit this concept later, but right now I just want to focus on changing that decimal to a fraction. So we'd write it 93 over 100. What about the next one? How would I write it? 75 over 100. And what about the next one? 33 over 100. You're probably not going to be able to reduce these fractions. In a very rare case, you may, but most of the time you won't reduce them. If you can reduce them, go ahead and reduce. 75 over 100, yes, could be reduced to 3/4. Okay, most of the time they can't, sometimes they can. All right, and then in our last example, in example 6, I am ordering the numbers from least to greatest. Okay, well, what problem do you see here right from the start?
Some are decimals,
Some are decimals and some are fractions. All right, well, here's the thing. I could change them all to a fraction, but if I do that, what am I going to have to find? The LCD. Okay, so if I convert them all to decimals, I can just compare them. So in these, you're just going to convert them all to decimals. I want you to go ahead and take a minute to convert all of these numbers to decimals. Write the original numbers first and convert them to decimals underneath. All right, so negative 5/4 becomes negative 1.25, negative 0.2, 4.31, negative 3, 2.5, and what's negative 13 over 3? Negative 4.3 repeating. Okay, so now that I have them in all decimal form, now I can order them least to greatest. All right, so what is the very least number in this data set? Negative 4.3 repeating, but what is it in its original form? Negative 13 over 3. And that's what I write in my answer. Remember, you're going to write these in their original form. What about my next smallest number? Negative 3. Very good. What about my next smallest number? Negative 5 over 4. Very good. What about my next smallest number? Negative 0.2. What about my next smallest? 2.5. And then my largest number will be 4.31. Wait. What did we do wrong?
We did for 2.5.
Very good. For 2.5, that's not its original form. It's 5 over 2. So make sure you write it in the original form. Did we do that for any others?
No.
Did we get them? Okay, and that's going to be our final answer. You have 2 of these on your homework tonight, so make sure you do them right. Okay, and if you understand that, that's everything you need to know for 5.1.